G'day, today's video is a bit different. One of the guys at work's son liked my measuring round things video, and so I thought I'd share a few of the tricks I use to measure, well, straight things, non-round things, when the usual tools, which are digital calipers, micrometer, dial indicator, and even dial test indicator, aren't quite enough to do the job. So I'll be showing you a few of the techniques I use to measure in awkward spots, as well as a couple of more specialist bits of equipment that I have that occasionally get hauled out to do special measurements. Supposing I wanted to know how far that bottom surface there, or maybe that seat, was from this top flange. Now, if I were using my calipers, that won't reach. Okay, so one trick I use for doing that is I'll get something like a steel rule or a straight edge, zero it, put that over the gap, and then do the depth measurement. Okay, by zeroing it on the rule, it effectively takes the rule off automatically. So from that surface where the rule was resting to the seat is 40.87 millimeters. Normally to mark out a line on a bit of metal like that, I'd probably use something like some odd lead calipers. These are a special one I've modified to put a screw on them to keep them there. The blue I'm using here is just a texture, by the way. And so I could do that quite easily. However, you know, what happens if I've left these in my other pants or something? Well, you can use a normal set of dividers, but what you can do with that is use them as a fence. I use the steel rule as a fence, so you can then run the dividers along and get the same effect as you would with the odd lead caliper. Another one you can do if you haven't got quite the right measure equipment with you. Suppose I want to know what the width of that groove is, and I haven't got a set of calipers here or something. Now I can use a drill bit, and if I get lucky I might get the right drill bit and I might have the right hole size. But what I can do is use feeler gauges just to see what that's like. Now that one's too wide. What's that? 0.4. 0.4 doesn't quite go. 0.25 does. 0.35 just wedges in there, so that's 2.35. Now, strangely enough, that's about right. So that's another way you can measure particularly deep grooves. You know, you may not even be able to get the inside measurement surface of the calipers in there, so you could use a drill bit, or if you've got some pin gauges and some feeler gauges if you can't get it. Most of the techniques that I'm showing you here are using a micrometer or a set of calipers, but there are some tools that are especially adapted for doing things, and this is one of them. I actually bought this for some wood carving that I was doing because I wanted to know what the thickness was as the thing curved. But if you can imagine, once again, you know, looking at this part, getting in there to try and measure the thickness is going to be very difficult. So instead what you do with a set of tongs like this is you can go in there and say, well, that's, what's that, 130 thou thickness of that. One of the problems with using a micrometer is that if you've got something with a bit of a curve to it, and the tip of the micrometer is flat, then it won't give you a true reading as to what that point is there. It'll give you from wherever your reference is to the corners. So there are a couple of ways around that. First of all, a lot of manufacturers make special micrometers with points on them, or that sort of stuff. That's nice. I haven't got any of those, so I make do with a couple of things. One of the things I use is a mat pin. Mainly because it's got a sharp point on it. I can put some blue tack around the top of it there, like so, and I can use that in some calipers, or I can use it in a micrometer. If I use it in calipers, of course, I can zero that. And what that's handy for is if you've got something with a deep groove in it, such as, you know, a thread. Perhaps you want to know what the major to minor diameter is. Okay, that will tell you. Okay, that's one thing. So using a drawing pin or a map pin, something like that. The other one I use is a ball bearing. Use a bit of blue tack to secure it to the anvil of a micrometer. You do need to make sure it's bottomed out, and I can say, well, that's 6.35, which is 1/4 inch. It's a 1/4 inch ball. I've got good contact. Then I can come along and measure something cylindrical like that. I need to take off the diameter of the ball, but that will tell me what the thickness of that curved part is. Another interesting variation in the micrometer is this sort of thing. This is a Starrett 220 multi-anvil micrometer, and they work by, you loosen that jaw off and you can take that out and you can put in another type of anvil. That's a basically cylindrical round one. That's a flat one. This one's one I just made up the other day, and there's actually a separate video about that. But once again, using a ball on the end there, you can zero that out and get thin thicknesses or something in awkward to reach places. So sometimes you have to make some sort of adaptation for what you've got. But if you're careful about it and you understand the principles you're working with, it shouldn't reduce your accuracy enormously. I talked about measuring dovetails in another clip, but it's probably worth just running through that one again. So basically, to measure the inside dovetail like that, a couple of dowels, and use your calipers or something like that to measure there. If you're measuring the outside here, then you need a block, something like that, which will sit on there and sit on there, and that will let you measure there, do a bit of a comparative measurement. This last one is not simple, but it can get you out of trouble. If you've got a large radius like this, you don't know what it is, you haven't got room to get a diameter in there, there is a way you can do it. If you're using a couple of precision ground pins, so dowels, you can set these up, and then using something like a depth mic, being careful not to touch the sides there, you can work out how far beneath the plane that joins those two pins this one is. Now, because you know the relationship of all these, you can then draw that up in a CAD package. It doesn't have to be terribly sophisticated. I've got a 20-year-old copy of AutoCAD which I use for this sort of stuff. You can then draw up your pins, how far down this one is from these two, that they're in close contact, and then put a radius on there, and that'll tell you what the radius is. So by using some simple things that you might have sitting around the place and some simple measuring, you can work out more complicated things. Anyway, that's a few measuring tricks that I occasionally use. Thanks to Oliver for asking the questions, I guess.